We will be taking a look at in the Softbody example today, okay, which is duplicate make original soft within Softbodies. Okay, so within Softbodies, there's duplicate make original soft, and this is what it will look like. Uh, we have this nice mini who is basically emerging from this lamp, and it is obviously is a genie and should have this jiggly and this illusion of kind of a soft like look to it, and which is giving me this soft look to it, okay, and a little bounciness on it. Okay, so let's see how this can be done. Let's very quickly start with the tutorial. The idea over here is to uh, have this gin like uh, emitting from this lamp, okay, gradually increasing in its volume, okay. And let's see how we can do it. We will be using Maya particles soft body for this, okay. So kind of which creates an illusion of while this chin kind of emits from this lamp, he will have a kind of a jiggly motion to him, okay, as he kind of emerges from this lamp. Okay. Uh, so let's see how this can be done. Okay, so uh, what we will be doing over here is we will be looking at as I mentioned, it's a soft body, and within soft body we will be looking at what will be the duplicate make original soft. Now we have seen make soft, we have seen what is duplicate make copies of the, so this time it will be duplicate make original soft. Okay, so let's have a look at it. Now I'll be selecting this asset of mine, the mesh of mine, and uh, so previously we have been creating the soft body and applying the soft body uh, to the mesh directly by using duplicate make copies of. Okay. In this case, we'll not be doing that because this will be simply creating too many particles uh, within the mesh, okay, based on its vertices. Okay, so if you can see this asset will have quite a bit of vertices, and if I create duplicate make copy soft, it's going to create a copy and have vertices being created on each of its particles being created on each of its vertices. Okay, that will be too much. It will be too difficult to evaluate. Okay, so rather, what I'll be doing is I'll be creating from the deformers menu. Okay, that is, I'll move to the animation, and there is a deform menu wherein which I will be creating a lattice. Okay. I now I'll be increasing the divisions within the lattice. So within S7 will be all right. Okay. And then within U I'll just have one. Okay. So that will be a good number. Okay. So probably, I don't know, maybe here. Yeah. So the idea over here is maybe a little less. Yeah, this will do. Okay, don't want too many in there. So within lattice, we will see that each of these uh, uh, component within lattice will control that region within the mesh within that quadrant, right? So you can see when I move this, it's controlling the mesh within that quadrant, right? And that will make life easier for the soft bodies in the sense I will be making the original soft, meaning this lattice is an origin, and that is something I'll make softer. Okay. So how do I do that is just select the lattice and make original soft and then just apply. Now in this case I'll be using so in uh, within the effects menu, yes, of course, in the particles we have two soft bodies. One is the actual and particle soft body, and there is another one which is the legacy one. Both works the same, except you know that this will have the nucleus within it. So uh, not an issue. You can use any one of these. Okay. We won't be, of course, using any of the n particles parameters within this. This will go true for both of them for this particular example. Okay. So yeah, soft body and what is the option? Duplicate make original soft. All right, everything good. Just say apply. Now this was going to create particles, as we all know that we will be able to see the particles on the lattice component, vertex components of the lattice. Okay. If we want to check it, you can go to the particle shape. You can go to the shape node. Since no, I'm sorry. Go to the emission attribute. Where is it? Okay. Hold on. So will be in the particle uh, particle size. Um, Display attributes need to be over here. Think dynamics. Yes. Yeah. So I'm sorry. So here in case of shading attribute, if I change this to sphere, okay, and then reduce uh, the spheres, say if I you have a sphere data type, right? So I'm just going to reduce the okay, I will need to turn on the all right, no issue. So but here is where we can see the particles which are being created on the lattice. Though we don't want them to be this, we don't want them to be sphere currently. We'll just keep it to points. Okay. So the idea here is was to show that there are particles which are being created, and if I play this of course nothing is going to happen. Okay. Now before going ahead with any kind of simulation, we will also need to check whether within the settings, preferences, in the time slider, we have something called as play every frame and 24 frames per second. Now, this will be important because for any kind of simulation to be uh, evaluated, it should evaluate at every frame. Okay. So this, if this is normally 24 frames per second, if somewhere set to 24 frames per second, uh, what this will do is trying to keep up with the frame rate. It is going to skip the frames and then uh, the it won't evaluate correctly, and you might see weird output over here. So rather, in any kind of simulation, whether it's particles, whether it's enclosed fluids, you need to see that this playback speed is always set to play every frame. The max playback speed will be 25. Okay. All right. So I do have particles now. I will be applying some kind of dynamics to this particle. I want the particles to move, so I'll be selecting the particles and applying a turbulence to it. Okay. I'll reduce the attenuation to 0. Okay, and have the magnitude set to 10. And we know that by default the particle subbody weight, goal weight is set to zero point 0.5. Okay, so let's play this. There we have a little moment. The reason is the goal weight is controlling, right? Goal weight is controlling the particle, and it is having a weight of zero point 0.5, and that's why it's the particles not going anywhere. They slightly move when they come to a rest. Okay, so instead what I'll do is just change this to zero point 0.2, and let's see what happens then. Okay, so if I now play, you see there is a bit of a movement in the, now there the particles are being released. The goal weight is being set to zero point 0.2, and the particles move on, but they're still connected, right? They kind of rotate around the kind of, not rotate, they kind of move around the vertex, right? All right, so now what do I do? Okay, I will be creating one more emitter. Okay, I will need to create an emitter from here. And then that emitter will have its own particles, right? So first let me go to the end particles, create, and the option is set to 0.90. Okay, so based on that, it is going to create an emitter, right? So I'll just create one which is omni, and I'll just say create. Okay, so that's, and just drag it a bit up close to the nozzle of, of the lamp. Okay, so something like that, and it would, of course, that will start emitting particles. Now I don't want the gravity on these particles. Okay, so I'll move to the nucleus and change the gravity to 0. So I don't want any kind of gravity active. Okay. All right. So there is now the particles emitting through the second particle which we emitted. Okay. Now the idea over here is that we don't want these particles. We do want the emitter which we have created for the second one, but we don't want the particle. Okay. So what I'll be doing is I'll be deleting these particles. Okay, the emitter will stay. But we know that we already have the particles which are on the lattice. So we will be making use of those particles as well as the emitter. In a way, I want to now have the particles which are on the lattice being emitted from the emitter which we have created. Okay, so how do we do that? Okay. I'll be selecting the lattice particles, I'll be selecting the emitter and specifying that use selected emitter. The selection is important. First the particles, okay, then the emitter, because I want the particles to be emitting from this emitter, and then go to the end particles and say use selected emitter. Alright, so here it gives me result, meaning that it has worked. Okay. So now this is not necessarily going to give you a quick result of any kind, because we will need to specify this somewhere. Okay, so within the lattice point, if I go to the attributes, there's something called as enforce count from history, okay, which is typically on right now. Okay, and I will need to turn it off. So it won't enforce it really from the history, the particle emission. So I tend to make this off. Okay, and now if you check, we get this result now. Okay. But eventually we want the particles to be emitting from the lamp. Okay. So what can we do for that? So let's check some parameters out here in the emitter. So in the emitter, if I move to the emitter, few, there is kind of a rate of particle over here, and because now they are being emitted, these particles are being emitted from the emitter one, which is this one. What we eventually need here is, if I play this, you will see that it kind of launches in the air. And there are two attributes we need to understand. Is one is the rate, of course. The other one is the span. Okay. So here, if we take a look in the lifespan, it's live forever. Okay. So definitely, I don't want the particles to be living forever right now. Okay. What I'll do is change the span to constant. Okay, which is lifespan of one. Okay. So if I now check it, you see that there is lifespan 1, and the particle seems to be doing what over here is, if you see, it's kind of repeating. Okay. Just leave the initial one where the you can see the object, so just forget about that one. But here, if you take a look, you see now they are kind of emerging from that particular emitter here, and it typically lasts for 24 frames, right? And then eventually it again does the same thing. Okay, it starts, it's doing the same thing. Okay, so that's all right. We'll keep the lifespan to one. And one more thing which we will be doing over here in the emission attribute is taking the rate of particles to 0. Now we want this because I don't want any particles to be visible uh, before. Okay, so initially I don't want the genie to be there, and then gradually it will emit. Okay, so I will play this, and you see that at, say, after few moments, okay, when you play it, you see it, and then at 24th, 25th frame, after 25th frame onwards, you don't see anything. Okay, it just turns off. See, and this is where this is what I want. Particles shouldn't be visible at from frame 0 onwards. Okay, initially at least at the frame 0. Okay, so I will now select the particles, go to fill and solver, and I'll set my initial state to set for selected for the particles. All right, so initial set for selected. Okay, means that this, I don't want the particle to be visible at frame 0, and that's what we have done. We don't see the particle once 0. Okay, now what I'll do is take my emitter back to what it was. Okay, so it doesn't matter. Okay, you can have 50, 100, but I want the rate back again over here. Okay, so now let me play this. You see it's gradually now emitting. Okay, and now the problem again is the same, where we have, within the particles we have set the lifespan to 1. So what is happening? After every one lifespan, it starts emerging, or it's repeating the lifespan after 24 frames. Okay, so I'll change this to 10. So I'll give it enough time now. Okay, so if I play this now, there it is. Okay, so it kind of um, there's nothing initially, and then it kind of emits and forms this. Okay, all right. Now it's we have what we want, but we don't want a lot of jiggle going on in there. There's too much of jiggle happening. Okay, and that is because of the goal weight. So the goal weight for the particles, I'll maybe reduce it to, let's say, 0.3 initially. Let's see what works the best. So Good. Okay. Maybe point 0.4. I don't know what value will work best. Okay, that's too much probably. Okay. One more thing, it's having that momentum. Okay, the particle is having a lot of momentum. Okay, meaning there is a conserved value of 1, which we will need to reduce a bit. Okay, so I'll make it 0.98 or so. The value is very sensitive, so I'm reducing it to tag. That's it, and then you will see that it kind of maybe more. Yeah, maybe more. I don't know. I'll have to work between the goal weight as well as the conserve that as a manager to look over here. So point 0.3 as well as 0.97, maybe 97 will work best. Let's see. So I'm reducing the momentum a bit more. There it is. Yeah, that is reducing it. Okay, goal weight. I don't know, maybe point. I'm just trying it. That's too high. Okay, so I think 3.5 is best, or probably will 2. 2 will be a lot more jiggly again once again. So hold on. This looks better, I believe. Okay, so it still has the momentum, increases. Uh, you know, okay. I think that's good. 3, it's 2. I think I'll keep it 2.5, or maybe 3.5 will also be. Just that looks much better. Yeah, I think this is better. Okay. All right. So now I will need to just turn off my deformers over here. I don't want to see them. Also need to turn off my end particles, and I will just need to see my character. So I think that is this works well. Uh, and that's basically it, guys. So, okay. So the idea over here is to understand what softbody duplicate make original means. Basically is we'll just apply uh, the particles to the original object, okay, rather than making a duplicate. So ordinarily for geometry it will just make a duplicate of it, and that duplicate will hold the softbody. While here I use the lattice, and lattice is the original, of course, which is creating particles on the lattice, and in turn, the lattice is controlling this geometry. So rather, me controlling the geometry directly and using all that many vertices will be too difficult for me, which will be taking a toll on my system. I rather create a lattice with few uh, control points, and those control points will be controlled by the soft bodies, so, or the particles on the top. Yeah, so that's it.